Hi guys. Okay, so this video today is going to be reviewing multiplication and division with problem solving. And some of our problem solving strategies are number one, when you read a problem, you should be visualizing what's happening so you can comprehend actually like what is going on in the problem. Number two, you should think of a strategy that's going to help you solve it. Maybe you want to draw a picture, maybe a bar model is a good one. Maybe you just have equations on whatever it is that you describe, the thing that you need to do. You have to put it on paper because a lot of these problems, or all of these problems, are multiple steps. It's not like one thing and you're done. There are multiple things to do, so you have to make sure that you actually understand what's happening. So you either have already solved these and you are checking to see if your answers are correct, or after I read the problem, you can pause it and you can try it on your own by yourself first and then press play to check to see if you got it right. Or you can follow along and write down as we go to help you along. If you want a challenge, I suggest pausing it, you trying to solve the whole problem, and then listening. If you are like, I'm honestly pretty confused, then I would just listen and copy down what I'm doing, but pay attention to why I'm doing it. All right, first problem. Tim and Allie had 96 marbles altogether. So you should be picturing two people, and they have 96 marbles. Tim loses 24 marbles to Allie during a game, and now Allie has twice as many marbles as Tim. How many marbles did Allie have before the game? First of all, I'm looking and I'm realizing that this is a before and after because they were playing and they had marbles together, and then Tim lost some, and now we have new numbers. So I'm going to be doing kind of two parts. I have a before when they were playing and an after when Tim loses them. These are confusing. I think you should just go line by line and just readjust your bars or readjust whatever you need as you go. Tim and Allie, so I know they're my two people. I've got Tim, Allie, had 96 marbles all together. That doesn't mean Tim has 96 and Allie also has 96. It means together, my whole is 96. So far, that's what I have. Tim, so now Tim loses marbles to Allie. If he's losing marbles, then I'm going to be switching to my after. Right now, I really don't know how many they started with. I'm just going to put two bars that are about the same. I'll fix them later if they're wrong, okay? So now we're moving to the after. Tim is losing 24 marbles to Allie during a game. So Tim is minusing 24, and Allie, obviously, is adding 24 marbles because I guess Allie won. Cool. Now Allie has twice as many marbles as Tim. So I know that Allie has 2 times the amount of Tim. So if Tim has 1, then Allie has to have 2 because 1 times 2 is 2. All right, how many marbles did Allie have before the game? Oh, my question is in my before. I'm really trying to figure out this. Now, if you're looking at this and right now you're like, okay, cool, now what am I supposed to do? You have to stop and think about what you know. If I look at the before is not helpful. I only know that they have 96, and that's all that I know. There's nothing I can do with that. So I'm going to focus on the after where I at least know some things are happening. Now, I'm noticing that I have 3 equal parts, which is great. If you could make equal parts, that's ideal. I am noticing, though, that I don't know any other numbers, really. So I had to think about what I do know about Tim and Allie. And what I do know is that this 96, has stayed the same because they're together, they have 96 before, and together they still have it after. It's not like Tim lost marbles down the drain. He actually just gave some to Allie. They just transferred them between each other. So their personal numbers are different, but their whole, if you add them together, is still 96. Now, what I'm hoping that you see is that I have these 3 equal parts, and I have my whole. And so if I have equal parts, I can figure out what goes inside each. And I'm seeing that this 96 is hugging everything. So I know that if I take 96, this number and this number and this number are going to be smaller. And they're going to be in equal groups. So I know that my first equation is going to be 96, and I'm going to divide it by 3 because there are 3 equal parts. I know that if I have 9 tens, that means that everybody gets 3. If I have 6 tens divided by 3, everybody gets 2. So that means that this is 32, this is 32, this is 32. That's helpful. Actually, you know what? Before I move on, never mind. Now I'm going to think. All right, that's figured out. But remember, my question is over here with Allie is how many did Allie have before? Well, how many does Allie have now? Allie has 32 plus 32, which I know is 64. Allie has 64 now. Well, let's think about this. How would I figure out for first of all. The only other thing I know is that Tim gave her 24. So I'm assuming that if Tim gave her 24, that means that she had 24 less earlier. So I'm going to take my 64, and I'm going to get rid of whatever Tim gave her, because if I get rid of it, then that's what she started with. And that's 40. That must mean that Allie has 40 to begin with. There is a way to check this to see if you are correct, which I suggest that you do. So if I'm looking right here at 96, I know I don't have to, and I know that my answer to this is that Allie had 40 marbles. But if you are like, is that right? You could check it because now you have information. If Allie has 96 or if Allie has 40 and Tim has 96, I can't talk. If Allie has 40 and they both together have 96, I can figure out how many Tim has. I'm going to take my 96, get rid of Allie's, and that must mean that Tim has 56. So let's check. If Tim has 56 and if he is giving away 24, then I'm going to take his 56 and I'm going to take away the 24 to see if I get this 32 right here. Oh, and I do, so I know my answer makes sense. So if you need to check it, that would be a good idea. All right, moving on. A store owner buys 1,257 cans of paint. It's a lot of paint, so I'm picturing lots of cans of paint. Each can has 4 quarts of paint. So I'm picturing a can of paint, and inside this paint thing, this is all the paint, this equals 4 quarts, okay? If he sells 620 cans, so he's selling something, how many quarts of paint will he have left? All right, let's go line by line. So I have a store owner. I'm going to draw his paint. How many? He has 1,257 cans of paint, right? That's a lot of paint. Each can is 4 quarts. So I'm picturing if this is one little can, this is 4 quarts. I'm not going to draw 1,257 quarts or cans because that's insane. So I'm just going to do this to show there's a lot of quarts or a lot of cans, and every single one of them is 4 quarts. So 4 quarts over and over and over again. All right, that's cool. Now here's my thing. It says, if he sells 620 cans, so I'm going to think, I might even do this as a before and after, because that's how many he starts with. He's had his 1,257 cans, and he's selling 620. So I'm going to think of that's my 620, and he's selling them. If he's selling them, I'm hoping that you're thinking that you're subtracting, because he had this many and he got rid of some. I want to know how many does he have left. I want to know this piece right here. Well, already I'm looking and I see that this is my whole and I want to chop off a part. So I'm going to subtract how many he sold. And I got 632. So that must mean that he sells 632. He has 632 cans of paint left. Here's the problem. A lot of people are going to think that's the answer. They're going to be like, oh, I got it. It's 632. But it's not. Because it doesn't say how many cans does he have left, how many quarts does he have left. So you have to really stop and think, okay, he has 632 cans, or cans, right? How many quarts are in one can? There are 4 quarts in every single can. So that means that you're doing 632 4 times to figure out how many are there. That means that he has sold 2,540. Did I multiply wrong? 600. Did I subtract wrong? I did 1,002. Oh, I see what I did. See, this is why I copied that number down wrong. You have to be precise. Oops. That's a 7. Why is this working? I'm hoping somebody at some point caught that. Now I'm doing 637 times 4. I thought about that. I thought that doesn't make sense. 4 times 7 is 28. There we go. Okay, I'm so sorry. 2,548 quarts. So my answer is he has 2,548 quarts left. That one's a challenge problem because it's all about the vocab and understanding the language of it. All right, let's do another. I guess it's a gardener, a gardener packs 4,568 peaches. That's a lot. So I'm picturing thousands of peaches and him packing them into boxes. He packs most of the peaches possible, dividing them equally into 9 boxes. So I'm picturing he has 4,568 peaches and he's putting them into 9 boxes. If he has, and it says he gives away the remaining peaches, that's a clue that this problem is going to have a remainder because there's some left over. This is 3 parts. Part A, how many peaches are in a box? How many does he give away? And if he sells 7 boxes, how many does he have left? All right, that seems like a lot of work, but that's okay. We're going to have a positive attitude, and we are up to the challenge. I'm going to start from the beginning. A grower packs that many peaches. Cool. I'm just going to draw a box, and I'm picturing the grower, he has, or she has, 4,568 peaches. Cool. He packs the most peaches possible, dividing them equally into 9 boxes. Okay, so I'm looking at this bar, and I know that there's 9 boxes. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's box 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm picturing some of them are going in this box, some in this. He's dividing them all up. All right. And then he's giving away the remaining peaches. So I'm going to say there's going to be a remainder. Okay, I'm going to stop right now, and I'm going to look at my first question. How many peaches are in each box? That means that I'm going to know how many are in each of these individual boxes. So I'm hoping that you're looking at this problem and realizing that I have a whole, and then I'm trying to split it into equal groups, which is what we would do when we divide. So my first, and I'm going to number that so I know, and I'm going to divide it by 9. If I have 4,009 boxes, I can't divide that. So I have to regroup my 4 into 400s. Now I have 4,500s divided by 9. Well, I know this number ends in a 5, so 5 can go into it. So I know that 9 times 5 is 45. Then I have 6 tens. If I have 6 tens in 9 boxes, that doesn't work. So I have to regroup that to be ones. Now I have 68 ones. Oh, time out. I missed a step. If I can't do this, I have to put a 0 there because I couldn't split that up. Now I have 68 divided by 9. If you aren't sure what that is, then you might have to skip count on the side of your paper. There's 63, that looks close. That's 1, 2, 3, 4, 5, 6, 7. 63. Okay, well, I have 63 to 68, so I'm going to have a remainder of 5. So I know that that goes here. So inside each box are 507 peaches. So I can answer part A. It says how many peaches are in each box? 507. Part B, how many peaches does he give away? It says up here that he gives away the remaining. He has 5 remainders, so he must give away 5 peaches. All right, now here's the question. If he sells 7 boxes, how many does he have left? Well, if I'm looking, I see all 9 boxes. We sell 7 of them. So 1, 2, 3, 4, 5, 6, 7. They are all sold. The question is, how many does he have left? Well, if I look at this and I know that 509 is in each of these, and I want to know how many he has left, I can just do 509 times the 2 boxes I have left. And I get 1,000. Did I do that wrong? Why do I keep doing this? 500. Guys, I have a problem today where I keep writing down this problem wrong. 507. Or maybe I can't read my own handwriting. 507 times 2 is 14. And that means that inside these 2 boxes, he has 1,000, or she, peaches. Hang on, somebody's at the door. I'm going to put up the next problem while I answer the door, and you can solve it. All right, the next problem is Alan, Bob, and Candy sold tickets to raise money for charity. Alan sold 125 tickets. Bob selling 14 times as many tickets as Alan. That's a lot. Candy sold half as many tickets as Bob. How many tickets did they sell altogether? Same, you shut the door on the way out. Thank you. Okay, so I'm going to stop. I have 3 people and they're selling tickets. I'm going to start from the beginning. I have Alan, Bob, and Candy. A, B, and C. They are selling tickets. Cool. Alan sold 125. I love that. They tell us exactly how many Alan has. Bob sold 14 times as many. That means that Bob sold a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There we go. Cool. Candy sold half as many as Bob. Well, hang on. If Bob has 14, what's half of 14? I know that's 7, so that must mean that Candy sold 7 boxes. I'm going to try to line it up so it looks right. All right. How many tickets do they sell all together? I want to know the whole. If I want to try to find the whole, I should be thinking that I'm going to get a big number because I want to put all of these things together. Now, I'm looking at this and I literally only have one number, 125. That's all that they're giving me. However, I do know that I have all these boxes with dots in them. So if this box is 125, so is this one, this one, this one, this one. All of these, all of them are all 125. So I'm going to count how many I have. I know that I had 14 here, and then I had 7 here, and I have 1 here. So I'm going to add them. If I add 7 plus 1 is 8, and 14 plus 8 gets me to 22. And I'm going to do, there's 22 boxes, and every single one is 125. I know that I'm going to do 125 times 22. And I know when I do 125 times 22, that's really 125 times 2 ones and 125 times 20. I'm going to start in the ones place. So 2 ones times 5 is 10. 2 ones times 2 tens is 4 plus 1 is 5, so that's 50. 2 times 100 is 200. Now, I finished my ones, but now I'm multiplying not by 2, I'm multiplying by 20. So that means I'm in the tens place. So if I'm multiplying by a 10, I know I'm not going to have any 1, so I have to put a 0. 2 times 5 is 10. 2 times 2 is 4 plus 1 is 5. And 2 times 1 is 2. So now I'm going to add up these together. And I got 2,750. So that must mean that altogether they have 2,750 tickets sold. And I got that one. All right, let's do another. Oops, I skipped one. Sam runs laps around a rectangular field 4 times a week. All right, so I'm picturing him running around a track, I guess. The field is 320 meters long and 240 meters wide. He's running 6 laps each time. Sam is a good runner. What distance does he run in a week? Well, okay, so I'm going to stop. I've got this guy, Sam, and he's running laps around a rectangular field. So that's what I'm going to draw. A rectangle. Well, that doesn't really look like a track. Cool. Got it? And I'm going to draw. There's Sam. He is running it 4 times a week. I'm just going to write that right there so don't forget it. The field is 320 meters long and 240 wide. Long means the longer part is how long it is. And wide is the shorter part, so I'm going to put 240. Now, because I know about a rectangle and its dimensions, if Sam is running laps, I know he's going all the way around. So he's running 320 here, 240 here. This is also 320, and this is also 240 because opposite sides of rectangles are equal. All right, cool. He's running 6 laps each time. So I'm picturing Sam right now going 1, 2, 3, 4, 5, 6. Sam is running a lot. Whew, okay, first what I'm thinking is I'm going to figure out, I don't even know how much 1 lap is. So I'm going to figure out how much 1 lap is. If he's starting here, going all the way around, I need to add up all of these numbers. So I could do it 2 ways. I could do 320. I could add them all up at once. Or I could do like 320 times 2 plus 240 times 2, whatever you want, whatever makes sense to you. I'm just going to add them. 8, 9, 10, 11, 12. 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, I'm bad. 6, 7, 8, 9, 10, 11. That's 1 lap. 1,100 jeepers. How many in meters? That is 1,120 meters just for one lap. Okay. Now, I'm going to stop and think. He runs 6 laps, guys, every single time he goes. So that's just 1,120. 1,120. 1,000. He keeps doing that 6 times. So I'm going to take his one lap. So that's my number 1. I did that equation first. I'm going to take his one lap, and I'm going to multiply it by 6 because he runs it 6 times. And that means that each day that he runs 6,720 meters. I'm going to label it because meters, miles, kilometers, they're all different measurements, and I want to make sure that I know what I'm doing. All right, now I'm not done because I'm forgetting about this piece right here, is that he runs this 4 times a week. So maybe he runs like Monday, Tuesday, Wednesday, and Thursdays. So this would, like, this right here is just like a Monday. He needs to also do this Tuesday, Wednesday, and Thursday because he runs it 4 days a week. So I'm going to take how much one day is, that's 6,720, and he does that 4 times a week. So I'm going to multiply that by 4. And I get 26,880 meters in a week. That's a lot of running. So I'm going to write that down. He runs, 26,880 meters a week. That's a lot of running that this guy is doing. So that's okay, but we have everything we need. It makes sense. I'm hoping that after doing some of these problems, we're feeling a little bit better. If you are like, oh, I kind of want to try one more on my own, I think that the last page in the packet that you have is this problem. Some of you may have done it in class, but if you want to try it again, because just because you heard it once doesn't mean that you actually understand it, maybe you could try it again and then come check in and see if the answer is correct. I hope that if you have any questions, you ask your teacher, and I hope that we realize that although problem solving is hard, it is really good for your brain, and it means that every time you are being challenged that you are learning more, and I'm hoping we can see the positive in that. All right, bye guys.